Hello everyone, this is Dr. Sudhan Sharma from School of Computer and Information Sciences, Indira Gandhi National Open University, and today's session is about understanding sequence and series. Now, sequence and series is actually a detailed topic wherein we are supposed to understand about the arithmetic progression, geometric progression, arithmetic geometric progression, harmonic progression, as a result of which this session is decomposed into two sessions. This session is about understanding sequence and series 1. So I welcome you to this session, and the objectives of this session are in fact to understand the arithmetic progression, apply the formula for sum of n terms of an arithmetic progression. Thereafter we are also going to understand the geometric progression and determine the sum of n terms of a geometric progression. Now, what is an arithmetic progression? In order to formally understand in the form of definition, an arithmetic progression is a sequence of terms such that the difference between any term and the one term immediately preceding it is a constant. This difference is called the common difference. So, let us understand this statement with the help of some examples. Over here some sequences are given to you. The first sequence is 3, 7, 11, 15, 19. Now, what you are going to observe over here that the first term is 3, adding 4 to the first term, you are going to get 7, adding 4 to the 7 you are getting 11, adding 4 to the 11 you are getting 15, adding 4 to 15 you are getting 19. So that means there is a common difference of value 4. So what the statement says, an arithmetic progression is a sequence of terms such that the difference between any term and one term immediately preceding it is a constant. This difference is called common difference. So in the first sequence, the common difference is 4. Thereafter, let's go to the second sequence, 7, 5, 3, 1. So 7 minus 2 is 5, 5 minus 2 is 3, 3 minus 2 is 1, and 1 minus 2 is minus 1. So that's why the common difference is minus 2. On the same line of action, the common difference is not necessarily to be an integer value, it can be a fractional value also. Likewise over here, we are having the common difference of minus 1 by 4, because subtracting 1 by 4 from 1 you will get the value 3 by 4, subtracting 1 by 4 from 3 by 4 you will get 1 by 2, and similarly 1 by 4 by subtracting 1 by 4 from 1 by 2. So therefore the common difference is minus 1 by 4. But if the sequence is like it is all the terms are same, like was 2, 2, 2, 2, then the common difference is 0. Such a progression wherein some term is to be added to get the subsequent term, then such a sequence is called arithmetic progression. So in general, the arithmetic progression is represented by the expression a plus d, a plus 2d, a plus 3d, and so on. So the general nth term of the nth term in an arithmetic progression will be given by the expression a n will be equal to a plus n minus 1 into d, where a is the first term and d is the common difference, and nth term is there, we are supposed to find out. So the entire expression turns out to be a n is equal to a plus n minus 1 d. Now let's understand this expression with the help of a simple example. We are given an arithmetic progression a plus 2b, a plus b, a minus b, a minus 2b. Now looking at the pattern, we are continuously subtracting the value b, because a plus 2b minus b will be a plus b, a plus b minus b will be simple term a minus b will be a minus b. So the common difference is minus b, and the first term is a plus 2b. So by applying this formula, a n is equal to a plus n minus 1 into d, the first term, that is this serves as a plus n minus 1, and what is the common difference? It is minus b. Now solving this mathematical expression, you will get the answer a plus 3 minus n into b. So this is the nth term of the arithmetic progression given to you in this example. Now let's solve some more examples. Say at random we are required to find the 18th term or the 23rd term and the nth term of an arithmetic progression given over here. Now looking at the arithmetic progression, the first term is minus 11. What is the common difference? Common difference is the difference of these two values, that is minus 9 minus 11. That turns out to be 2, because by adding 2 into minus 11 you will get value minus 9, by adding 2 into minus 9 you will get the value minus 7. So common difference is 2. So what will be the 18th term? Will be equal to a plus 18 minus 1 into d. What is a? A is minus 11 plus 18 minus 1 is 17 and the common difference is 2. So that means minus 11 plus 34, that is equal to 23. So 18th term turns out to be 23. On the same lines you can calculate it for a23. So it will be a plus 23 minus 1 into d. So minus 11 into 22 into 2, that turns out to be 33. Same lines you can apply for a n, wherein a plus n minus 1 into d turns out to be 2n minus 13. I hope you understand what is an arithmetic progression, how to calculate the nth value or at random say 18th or 23rd or any value by following the formula a n is equal to a plus n minus 1 into d. Now let's extend our discussion to another important concept, that is the difference of two terms of an AP. Now say we are having an arithmetic progression a plus d, a plus 2d, a plus 3d and so on, and say we want to find the difference in between the two terms. Say there is an rth term AR and the s term AS. Now following the formula a n is equal to a plus n minus 1 d, the rth term will be equal to a plus r minus 1 into d and the sth term will be equal to a plus s minus 1 into d. Now subtracting as from AR, you will get the formula, you will get the expression a plus r minus 1 into d minus a plus s minus 1 into d, which is this expression. Solving this expression by opening the parenthesis and thereafter finally solving the expression, you will turn out with the final solution that it is r minus s into d. So this is the general formula, that is AR minus AS will be equal to R minus S into D. So let's apply the understanding of this formula by solving a numerical problem. Say example is which term of the arithmetic progression, AP's arithmetic progression, the given arithmetic progression is 3, 15, 27, 39 will be 132 more than the 54th term. So firstly analyzing the arithmetic progression 3, 15, 27, we identified that the common difference is 12. Now the nth term is required, so we are over here. What is the question? Which term of arithmetic progression will be 132 more than the 54th term? So the difference is given to you, that is 132. That is, if we follow this formula, that is the difference in between the two terms. Say the normal term, any general term is rth term, and we are given say 54th term is there, and this difference is 132. So applying the formula r minus s into d, we will get r minus 54 into common difference, that is 12, that is 132. Okay, we are applying this formula wherein r minus s, that is the 54th term, into d, the d is 12. So this turns out to be 132. Solving this expression, r minus 54 will be equal to 132 by 12, which is nothing but 11, and therefore R will be equal to 54 plus 11, that is equal to 65. So, it is the 65th term of arithmetic progression, which is 132 more than the 54th term. I hope you are able to understand what this expression is all about. Let me solve one more example for your better clarity. If pth term of an arithmetic progression is q, this is very important question. Generally, this type of questions are very much expected in entrance examination, in your term and examinations like also, and you can expect such questions in your MCQs for continuous evaluation. If pth term of arithmetic progression is q and the qth term is p, if the pth term is q and qth term is p, show that its rth term is p plus q minus r. What is this p plus qth term? Now, ap minus aq, that is pth term and the qth term, the difference will be equal to p minus q into d. We had already learned that AR minus AS will be equal to R minus S into D. This is the normal formula. So, substituting R as P and Q and S as Q, you will get it equal to P minus Q into D. Now, because the pth term is Q and qth term is P, so pth term is q and qth term is p. So, the left hand side turns out to be q minus p and right hand side turns out to be p minus q into d. So, that is why the common difference turns out to be q minus p divided by p minus q, and which turns out to be minus 1. So, common difference d is equal to minus 1. So, that means AR minus AP or AP minus AQ, whatever you want to say, will be equal to R minus P into D, or you can say R minus P into minus 1. So, by solving this equation, you will find that AR will be equal to AP. By taking AP to the right hand side, you will get AP minus R plus P. So, this will give you the expression AR is equal to, what is AP? Is the Q as per expression. What is AP? AP is Q. Q minus R plus P. That means you can say that AR is equal to P plus Q minus R, which is very much required over here. So, one part is over. Apart from this, putting R is equal to P plus Q, R is equal to P plus Q in the expression AR, you will get A P plus Q. So, one expression is P plus Q, and by substituting R as P plus Q, what you will get? You will get the answer 0. So, what is the P plus Qth term? The P plus Qth term is 0. So, I hope you learned how to solve this type of numericals. Now, let us extend our discussion to the formula for sum of n terms of an arithmetic progression. Now, we already learned that S series is in fact sum of the terms. So, if an arithmetic progression is given to you and the sum of values for that arithmetic progression, whose first value is a, second is a plus d, third is a plus 2d, and another term is a plus n minus 1d, will be a plus a will be the sum of all those values. So, say this is represented by equation number 1. Now, if we are we write this expression given in equation number 1 in the reverse order, then what we will get? We will get this value. Adding these two terms, that is equation number 1 and equation 2 vertically, all the expressions are added vertically, what you will get? S plus S will be equal to 2s. And a plus n minus 1 into d, what you will get? 2a plus n minus 1 into d. Similarly, by extending a plus d into a plus n minus 1 into d, again it turns out to be 2a plus n minus 1 into d. So, by point-wise adding each and every value, say the last term is a plus n minus 1d plus a, their sum will turn out to be 2a plus n minus 1d. So, that means the entire sum turns out to be, this implies 2s will be equal to n times of the sum of 2a plus n minus 1 into d. That means sum is equal to n by 2 into 2a plus n minus 1 into d. So, this will be the expression for the sum of n terms of an AP, and if the last term is a plus n minus 1 into d of the AP, then the sum can be expressed as a sum will be equal to n by 2 into a plus l, where a is the first term of the AP and l is the last term of the AP. Because by applying this expression, so many a times an AP is given to you wherein the first term is given and the last term is given, you are supposed to directly find the sum of n terms, then you can use this formulas. We will explore, understand the formula by solving some numericals. Say we are supposed to find the sum of first 100 natural numbers. The formula for sum is this: n by 2 into 2a plus n minus 1 into d. So, 100 natural numbers are there. So, n will be equal to, n is equal to 100. So, that means by applying this formula, the solution will be 100 by 2. First 100, so first natural number is 1, the first value is 1. So, the AP will be equal to 1, 2, 3, 4 up to 100. That means a is equal to 1, common difference is also equal to 1 and number is n is equal to 100. So, applying the formula you will get 100 by 2, that is 50, 2a, 2 into 1, 2 into 1 plus 100 minus 1 into common difference is 1. So, that means 101 will be there and 50 into 101 is 50, 50. So, sum of first 100 natural number turns out to be 50, 50. Similarly, applying the same formula onto another numerical, find the sum of 23 terms and n terms of an AP 16, 11, 6, 1 and so on. The first term is 16, the first term is 16 and the next term is 11, next term is 11. So, that means the common difference is 5, common difference is minus 5. So, now applying the formula Sn is equal to n by 2, 2a plus n minus 1 into d, so 23rd term. So, 23rd term, so n is equal to 23. So, 23 by 2, 2 into a is 16, n minus 1. So, n is 23rd, so 23 minus 1 into common difference is minus 5. Solving the expression, you will get the 23rd value is minus 897. On the same lines, applying directly for the nth term, Sn will be equal to n by 2 into 2a plus n minus 1 into d. So, n by 2 is this, 2a, 16 into 2 is 32, n minus 1 into common difference is minus 5. So, solving this expression, you will get minus 5n plus 5. So, entire solution gives you the value that Sn is equal to n by 2 into 37 minus 5n. So, I hope you understood what do we mean by the sum of n terms of an AP and how we can apply this formula to solve several problems. Next, we are going to understand about the concept of geometric progression. The fundamental difference in between the arithmetic progression and geometric progression is that over in arithmetic progression, we are having the terms a plus d, a plus a plus 2d, and so on, a plus n minus 1d. But in the in geometric progression, we are having the terms like a into r, a r square, a r cube. That means each term is multiplied. Rather than adding, we are multiplying the term by a common ratio r. So that's why the successive terms are ar multiplied by r is ar square multiplied by r is ar cube, and so on. So, likewise, if we want to cite an example that a ball always rebounds exactly 70% of the distance it falls, then what is happening actually, say if a ball falls from a height of say 100 units, then it will rebound exactly 70 units. Thereafter 70% of the 70 units, that means 49 units, and so on. So, the actual factor is 0.7. So, firstly the ball was thrown from the height of 100, then it rebounds from up to 70%, that is 70% of 100. So, 0.7 into 100, then 70% of 100 into 0.7, that is why 100 into 0.7 square, and so on and so on. So, that means the successive terms are obtained by multiplying the previous terms by the fixed constant of 0.7. And such a sequence is called a geometric sequence or geometric progression. And the fixed number by which the terms are multiplied, they are known as common ratios R. So, the formal definition of a geometric progression is that if a1, a2, a3 up to an are in geometric progression, then a k plus 1 will be equal to r times of a k. So, the geometric progression looks like a into ar square into ar cube up to ar to the power n, and if it is infinite, then it goes ahead. So, the nth term of a GP is given by expression a n is equal to a into r to the power n minus 1, where a is the first term, and r is the common ratio, and n is the nth term for which you want to find the GP value. Now, similarly, as we did it in the arithmetic progression, we find the difference in between the two terms. In the geometric progression, because the terms are being multiplied, so the concept is extended to the ratio of the two terms in the GP. So, if a given geometric progression is ar square, ar cube up to ar to the power n minus 1, then the ratio of the two terms, that is the nth term and the mth term, will be equal to ar to the power n minus 1, and mth term will be the value will be a to r to the power m minus 1. So, ratio of the two will be this one. By solving the expression, a will be cancelled out. So, taking the numerator to denominator and by adjusting the exponents, you will find that r to the power n minus m is actually the ratio of the two terms which are in geometric progression. So, an by am is equal to common ratio to the power of n minus m. Now, let us apply this formula to solve some of the examples. Over here, the example is find r and the next four terms of the geometric progression: minus 3, 1, minus 1 by 3, 1 by 9, and so on. Now, here the first term is minus 3, and the next term ar is equal to 1. So, next term ar is equal to 1. So, that means the common ratio will be equal to ar by a, that is equal to 1 by minus 3. That means common ratio is minus 1 by 3. So, the next four terms of the GP, so 1, 2, 3, 4, so we are supposed to find the fifth term. So, fifth term will be equal to common ratio r is to be multiplied to the fourth term, then only we can get the fifth term. So, that means a4 into r. So, what is the fourth term? a4. This is your a4. So A4 is 1 by 9 into R, that is minus 1 by 3. 9 3 is 27, that is minus 1 by 27 will be your fifth term A5. Similarly, you can find A6 and A7 and you will get the values minus 1 upon 87 and minus 1 upon 243. And on the same lines, you can get A6, A7, A8, whatever. So you can calculate the values by simply applying the formula, which is A n by am r to the power n by m. Now, there is one more example. Determine the 12th term of the geometric progression whose 8th term is 192 and the common ratio is 12. So, we are supposed to determine the 12th term. Determine the 12th term of the GP whose 8th term is 192 and common ratio is 2. So, we are already aware of the formula, that is an by am is equal to r to the power n minus m. An by am is equal to r to the power n minus m. So, an is 12th term, say am is 8th term. So, our common ratio r is there, 12 minus 8. So, that means r to the power 4, and what is r? R is 2, 2 to the power 4. 2 to the 4 to the 8 to the 16, and A8 is given to be 192. So, that means A12 is equal to A8 into 2 to the power 4, that is 192 into 16, and that turns out to be 3072. So, this is the 12th term of the geometric progression. Now, on the same lines, we are supposed to find the sum of n terms of the geometric progression. Now, let the sum of the n terms of the geometric progression is a plus ar square up to ar to the power n minus 1. And in order to find the sum, let the procedure be that multiply both sides of this equation by r. So, if we multiply both sides of this equation by r, then what we will get? We will get r into Sn is equal to ar square, ar cube, ar n minus 1 up to ar n. Now, in order to find the general expression for the sum of n terms of GP, we are supposed to subtract equation 1 from equation 2. And our subtract 2 from 1, you will get 1 minus r Sn. So, subtracting these two values, you will get 1 minus r Sn, and thereafter subtracting all these values. So, this will cancel out, this will cancel out, this will cancel, and so up to this all terms will cancel out, and finally this term and this term are remaining. So, that means finally you are getting a minus, so you are getting 1 minus r Sn is equal to a minus a r to the power n, that is equal to a 1 minus r to the power n. So, that means Sn will be equal to a 1 minus r to the power n by 1 minus r, and this is nothing but the sum of the nth term of the GP, that is a into 1 minus r to the power n upon 1 minus r. Clearly, if r is equal to 1, then sum will be equal to a plus a plus a plus so on up to n terms. So, that means sum will be equal to n times of a. So, if r is equal to 1, then sum will be equal to na. And if r is between minus 1 and 1, then sum of infinite GP will be equal to a upon 1 minus r. These are the important observations, that if r is not equal to 1, then sum will be sum of n terms of GP will be given by expression Sn is equal to a into 1 minus r to the power n upon 1 minus r. If r is equal to 1, then sum is equal, given by the expression Sn is equal to Na. If R is in between the interval -1 to 1, then sum of the infinite GP will be given by the expression Sn is equal to A upon 1 minus R. Let's extend our discussion by solving some of the numerical problems. Say, firstly, we are supposed to find the sum to 20 terms of a GP 128 minus 96, 72, minus 54 and so on. So, the first term is 128 and AR, that is the next term, is minus 96. So, A is 128, AR is minus 96. Therefore, the common ratio will be equal to minus 96 upon 128 and that turns out to be minus 3 by 4. Now, since R is not equal to 1, common ratio that R is not equal to 1. So, by applying the formula again, A into 1 minus R to the power n upon 1 minus R, that is this formula, you will get A is 128, 1 minus R is minus 3 by 4 to the power 20 upon 1 minus R. R is again 1 minus 3 by 4. By solving the entire expression, you will get the answer to be this. So, it will take some time. Try to solve the expression by your hands, by applying pen and pencil mechanic, solve this expression. Now, example is there, one more example is there, that how many terms of a GP root 3, 3, 3 root 3 all adds up to 39 plus 13 root 3. So, first term is root 3, so A is root 3, AR is 3, AR is 3. So, the common ratio R is equal to 3 by root 3. So, that means the common ratio is root 3. Now, let 39 plus 13 root 3 be the sum of n terms, then that means it is given that Sn is equal to 39 plus 13 root 3. Applying the formula A R to the power n minus 1 upon R minus 1 is equal to Sn, you will get A is root 3, R is root 3 to the power n minus 1 upon R minus 1. Now, because why we are applying this formula? So, by solving this expression, you will get that the entire term turns out to be, the entire solution turns out to be 3 raised to power n by 2 is equal to 1 plus 13 into 3 minus 1, that is 27, and 27 is nothing but 3 cube. So, that means by comparing the powers, over here the power of 3 is n by 2, over here the exponent value is 3. So, n by 2 is equal to 3, that means n is equal to 6. So, that means it requires 6 terms of this geometric progressions to obtain the sum equal to 39 plus 13 root 3. One more example and you will understand this expression, this concept in a better manner, and I again require you to attempt more and more problems given to your self-learning material, so that you better understand the concept. Now, let us solve the example. Find the sum of n terms of the series 9 plus 99 plus 999 plus so on. Now, we can write 9 as 10 minus 1, 99 as 100 minus 1, 999 as 1000 minus 1 and so on. So, that means entire expression of this series, this one can be rewritten as 10 minus 1, 10 square minus 1, 10 cube. What is this? 10 cube. What is this? 10 square. What is this? 10 to the power 1. So, 10 to the power n minus 1. Opening up the braces, you will get the expression 10 plus 10 square plus 10 cube up to 10 to the power n, and all these 1 are added up to n terms. So, all 1s are added up to the value n. As a result of which, you will get sum of n terms will be equal to 10 to the power n minus 1 upon 10 minus 1, and this is equal to n, minus n. So that means the entire expression turns out to be 10 into 10 to the power n minus 1 upon 9 minus n. I hope you learned about what is arithmetic progression, what is geometric progression, how the concept of arithmetic progression and geometric progression are applied to solve the various problems. Try to practicize more and more problems given into your self-learning material, and you will better understand the concepts. Thank you.